Hi there. Today we're going to be talking about solving one variable inequalities. Now it's important that we understand what an inequality is. And that's when two things are not equal, that one is going to be bigger than the other, okay? And what I'm going to do is I'm going to look at a number line here, okay? Because a number line is going to help us determine how to understand inequalities a little bit better. Now, if I go to the right on a number line, then that means that we're going to be big. Now, if I go to the left, that means that we're going to be small, okay? And we use the following symbols to talk about inequalities. This symbol right here and this symbol right here stands for the phrase less than, okay? This one is strictly less than, this one is less than or equal to. So if you have the line underneath it, it means that it's also equal to. This symbol over here says it's greater than or equal to. So if you have the line underneath, it means that it could equal that number. Now what I'm going to do is I'm going to compare the numbers -1 and 5. And I've plotted those on the number line. Now I want to determine which one's bigger than the other. Now looking at a number line, -1 is located right here. 5 is located right here. Now the number that's further to the right is bigger than the one that's further to the left, okay? And you can obviously know that 5 is a larger number than -1, okay? So what I want to do is I want to write this using my less than notation or my greater than notation. And all I would say is this, that -1 is less than 5, or I could say that 5 is greater than -1. Those things mean the same thing. Now I could also go in there and say -1 is less than or equal to 5. That would also be true. Or 5 is greater than or equal to -1. Now, the other thing I want to do is talk about the shark, okay? And when I grew up, I thought of this as like a Pac-Man eats the bigger number, okay? And if you ever played the game Pac-Man, that Pac-Man eats things, and so it's going to eat. Now, I like to think of the shark. And I think of the shark because I'm such a big fan of the movie Jaws, okay? And I think I'm really good at drawing sharks, but you can also think of that, all right? So it's going to eat the bigger number, and that's how I look at this. Now, let's talk about an extension of this, which is solving an inequality. And when I'm solving an inequality, I solve them the same way as I would any linear equation. Except the only difference is that if you multiply or divide by a negative, then you must reverse your inequality, okay? I'll talk more about that here in a second, but what I want to do is this. I want to go through a couple of examples on how I solve an inequality. So let's say I have the inequality 3x minus 2 is greater than 19, okay? What I want to do is solve this inequality for x, okay? Think of your inequality as an equal sign, okay? And some of you even do this, where you draw your line down the middle, okay? And that's totally fine. But what I want to do is to do my steps to solve any equation, okay? And it's going to, remember, we want to think about the opposite. So if I'm subtracting 2 here, then what I would do is I would add 2 to both sides, okay? That's my first step. -2 plus 2 cancels out. I'm left with 3x is greater than 19 plus 2, which is 21. Now I'm going to divide by 3 on both sides. Now look what I'm doing. I'm dividing by a positive number, so I don't have to do anything to my inequality. But then as a result, what I end up getting is I get the statement x is just greater than 7, okay? And that's how you solve an inequality. Now let's say that you had this as an example. And this inequality is 4 minus 2x is less than 18. So what I'm going to do is this. I'm going to go ahead and use my same operations. I'm going to subtract 4 from both sides. And we're going to get negative 2x is less than 14. And then I'm going to divide by negative 2 on both sides. Now, since I'm dividing by a negative on this, what I want to do is I want to reverse my inequality symbol. So the negative 2's are going to divide out, and I'm left with x is greater than negative 7. So you're probably wondering, how come you have to do that? And let's think of an example of why we have to do that. And what I want to do is think about what we already had. And that inequality was that negative 1 is less than 5. We can all agree that that's true. Now, I can do any operation on this to both sides, and it's going to remain a true statement. But watch what happens if I do something, okay? If I multiply both sides by, say, positive 2, okay, then we get negative 2 is less than 10. That's a true statement, okay? So both of those are true. Now, if I take that same inequality, negative 1 is less than 5, and let's say I multiply both sides by a negative 2, all right? And I'm multiplying by negative 2, then what we're going to get is we're going to get positive 2 is less than negative 10. So we started off with a true statement, and now we have a false statement. And the only way that we can make that true again is by reversing our inequality and writing this as 2 is greater than negative 10. That would make it true, okay? And you could even write this as negative 10 is less than 2. Doesn't matter. They mean the same thing, okay? Now, the next thing I want to talk about is called graphing inequalities. Now, I'm going to take this inequality that we got, that x is greater than 7, okay? And what I want to do is I'm going to draw a number line. I'm going to label a 0 somewhere on that number line, and then I'm going to label the number 7. And the 7 is going to be to the right of 0. I'm not trying to be too particular about this. I just want to show you how I graph. Now, when x is greater than 7, all I'm going to do is I'm going to then say, all right, well, what numbers would satisfy this inequality? What numbers could I plug in for x that would be larger or greater than 7? And that answer, those numbers would be something like 8, 9, 10. All of those numbers are going to be larger than 7, okay? So then, you know, I could even think about like 7.5, 7.75, 7.1, all of those numbers. And so what I do is I do this. If I'm graphing this, then I'm simply going to put an open circle around the number 7 and shade this to the right. And what that does is the shading shows me my solution set. All right, shows me where would my answers be if I'm talking about this inequality, okay? Now, I could even do this. I could say that x is greater than or equal to 7. Now, I'm going to do the same thing, and I'm going to have only one difference here. All right, I'm going to plot my 0, plot my 7, and I'm going to think about numbers that are going to be greater than or equal to 7. Those numbers would be numbers like 8, 9, 10, 8.5, 7.5. The other thing that would exist is the number 7, okay? And I'm going to put a big solid circle, colored in circle at 7, because 7, writing that statement, 7 is greater than or equal to 7, is a true statement because its 7 is also equal to 7. And then I would still just shade to the right, all right? So there's a small difference when we're talking about graphing inequalities. Now, the next thing I want to talk about is interval notation. An interval notation is something where I can write my solution as x is greater than 7. I can graph it, but I could also write interval notation and use the graph to help me. Now, this graph here starts at 7, and my solution set goes to the right. It goes to positive infinity. So I can write the solution set that parenthesis 7 to positive infinity. And that's how I would write that. Now, if I was talking about x is greater than or equal to 7, I would use the notation and say bracket 7 to positive infinity. So all three of these things mean the same thing. And what I'm trying to show you is that no matter if I use an inequality notation, I use a graph, or interval notation, I'm saying that my solutions are going to be between larger than 7, so in between 7 and positive infinity, or bracket 7 and positive infinity for this, okay? So hopefully that all makes sense, and we'll talk to you soon. Thanks a lot. Bye.